The third basic proportion type is partitive, where the quantities involved make up one whole. Welcome to Mathematics of Engineering. Let's reiterate what was just said earlier. In partitive proportion, each element is a part of a whole. So adding them all together will give you the number of parts or divisions in an entity. For our first example, a concrete mix is made up of cement, sand, and gravel in the proportion of 1:2:4. Determine the quantities of each component for 161 cubic meters of concrete. The proportion in this example is made up of cement, sand, and gravel in the proportion of 1, 2, and 4. Since proportion is unitless, you can use this with volume or weight. Having such proportion make up the concrete mix, we can say that they make up one whole. That is the concrete mix. So when we add all the proportionals, we take the summation of parts in one whole. That would be 1 plus 2 plus 4, making 7 parts. With the next given quantity of 161 cubic meters, we look for the volume of each component. First is cement, which has 1 part of the 7, so that's 1 part of 161 cubic meters over 7 parts, giving 23 cubic meters. Next is sand, that has 2 parts of 161 cubic meters over 7 parts, giving 46 cubic meters. Last is the gravel, with 4 parts of 161 cubic meters over 7 parts, resulting to 92 cubic meters. If we add volumes, we get 161 cubic meters, the total volume of the concrete mix. For the second example, the angles of a triangle are in a ratio of 5:6:3. Find the measure of each angle. This means the ratio of angles A, B, and C are to 5, 6, and 3. Those angles are used for a triangle, and we know that the summation of the interior angles of this polygon is 180 degrees. Thus, we can say that adding the ratios 5, 6, and 3 should be equal to 180. That's just like 14 parts in 180 degrees. Angle A is computed as 5 parts of 180 degrees over the total of 14 parts, and this makes 450 over 7 degrees, which can also be written as 64 degrees, 17 minutes, and 8.57 seconds. The next angle B is then solved as 6 parts of 180 degrees over 14 parts, which is simplified as 540 over 7 degrees. That is also 77 degrees, 8 minutes, and 34.29 seconds. The last angle is solved similarly as 3 parts of 180 over 14, and that is 270 over 7 degrees, which can be written as 39 degrees, 34 minutes, and 17.14 seconds. The third example states the complementary angles are in a ratio of 10:13. Find each angle measured. The ratio is for angles A and B, which is proportionate to 10:13. Making them complementary angles mean that their summation is 90 degrees. So the ratio of 10 plus 13 is 90 degrees. That would make 23 parts as 90 degrees. So to compute for the angles, start with angle A, which has 10 parts times 90 degrees over 23, making 900 over 23 degrees. That is just like 39 degrees, 7 minutes, and 49.57 seconds. Angle B, on the other hand, is 13 parts of 90 degrees over 23. That would be 1170 over 23 degrees, which can also be written as 50 degrees, 52 minutes, and 10.43 seconds. Example 4. In a triangle, the ratio of the base to height is 5:2. Find the dimensions of a triangle if the area is 80 square meters. In this example, we discuss the dimensions of a triangle, the base, and the height, proportioned as 5:2. The other given parameter is area, which is solved as half of the base with the height, for a triangle. If we assign one part as x, the solution becomes half of 5x times 2x as equal to 80 square meters. Simplify and get 10x squared as 160. Divide both sides by 10 and get x squared as 16. So x is solved by taking the square root of 16, which is 4. This is the single part. Identifying what one part is, we can then solve for the base as 5x, which is 5 times 4 meters, or that is 20 meters. The height is solved the same way. It is 2x, or 2 times 4 meters, resulting to 8 meters. Example 5 states, the length and width of a rectangle are in a ratio of 7:9. Find the dimensions of the rectangle if the area is 1008 square centimeters. The area of a rectangle is computed as the product of its length and width. Again, assigning x for one part, the area is then 7x times 9x as equal to 1008. Simplify this as 63x squared equal to 1008. By dividing everything by 63, we get x squared as equal to 16. Take x by computing their square roots, so x becomes 4. This is for one part. Now, length is then solved as 7x. That is 7 times 4 meters, which is equal to 28 meters. The width is taken as 9x. That is 9 times 4 meters, which makes 36 meters.